Now see nuclear reaction. See here in nuclear reaction, nucleus of the atom take part in the reaction. Suppose if you have got any nucleus like this take part in the reaction. When the nucleus undergo a change, new nuclei are formed. So entirely new nuclei you will be getting in this process. But in this process, during nuclear reaction actually there is a loss of mass, that is called equal to delta M, and due to this loss of mass energy is released. But as compared to chemical reaction, energy released in nuclear reaction is in large amount. Now see, there are two types of nuclear reactions actually here. One is nuclear fission and another one is nuclear fusion. So there are two types of nuclear reactions, one is nuclear fission reaction, another one is nuclear fusion reaction. Now let us discuss nuclear fission first. So now first we are going to discuss nuclear fission. So see here, in nuclear fission reaction, what happened actually here? In this reaction, a big nucleus take part into the reaction and it breaks into two middleweight nuclei. So in the binding energy per nucleon curve, we have seen the atoms which are having the mass number greater than 230 can take part in the nuclear fission reaction. If you take the example like a uranium 235, suppose you have taken that is a uranium 235 and it takes here one neutron, it is bombarded with a slow moving neutron. When it is bombarded with the slow moving neutron, it breaks into two fragments. One of them is a barium, that is a 56 141 plus krypton 3692 plus 3 neutron plus Q, that is energy released. So when nuclear fission of uranium 235 takes place, in the fission of one atom we have got 3 neutron over here and this Q is here. So when one atom undergoes a fission reaction, that means one fission takes place, Q is coming approximately 200 mega electron volt. It means a large amount of energy is released due to the fission of one atom here or due to one fission. Now see here in this, in one fission there are the 3 neutrons are here released. If these 3 neutrons are allowed for the further fission, it means the 3 neutron will cause the fission of 3 different nuclei of the uranium atoms. Then what will happen? You will be getting 9 neutrons and these 9 neutron will cause further fission. You will be getting 27 neutrons. By this way, within a microsecond, large amount of energy is released and this nuclear reaction becomes uncontrollable. And this type of the nuclear reaction is known as a chain reaction. So here, so nuclear fission reaction is a chain reaction. Once it is started, it will continue till all the uranium fuel gets used. But this reaction can be in controlled way and uncontrolled. It means controlled nuclear fission reaction and uncontrolled nuclear fission reaction. Uncontrolled nuclear fission reaction is actually used in the making atom bombs. In atom bombs like uranium or any radioactive material is used, nuclear fuel is used, which produces large amount of heat and harmful radiations, which gives a destructive effect. But in the controlled manner nuclear fission reaction, it means out of these 3 neutrons only the certain neutrons are allowed for the further fission, then the reaction can be controlled. If you are controlling the reaction, then this reaction can be used for generating power. You know the nuclear power plants here which are generating electricity, they are actually using generally uranium 235 as a fuel or the plutonium and they are used for generating power here. So using the nuclear fission reaction for generating power has got many advantages as well as disadvantages. Now let us see here the schematic diagram of the nuclear power plant. So how do we use nuclear fission reaction for generating power in nuclear power plant? So what happens in nuclear power plant? First there is a core is taken here. In core uranium fuel is placed and inside the core here the rods are placed like this. These rods are known as controlling rods actually here, maybe here the controlling rods, there is a barium or krypton And also moderator is used here inside this. Moderator we can use like a heavy water D2O, and then this core is here supplied with here the coolant from this side. The coolant is circulated. Coolant means that is here the water we can take, and here when this coolant comes in this chamber here, again here. So, in this case here, so this coolant as a water is circulated through this. So, when the nuclear reaction takes place inside the core, large amount of heat is generated. By circulating this coolant, this heat is absorbed, this coolant becomes very hot, and this coolant comes here and it gives out heat to the water, and the water gets converted into steam, and this steam can be used for generating electricity. So, this is the schematic diagram of the nuclear power plant. Actual diagram you can see in the books also, that is a different one, but here just to show the working of the each and every part. Moderators are used here, which are used to slow down the speed of the produced neutrons so that the further fission can cause, because for the fission of uranium 235 we need slow moving neutron. Now, advantages of nuclear fission reaction is here, only a small amount of fuel can give large amount of energy. There is no problem of replacing the fuel again and again as it is done in the thermal power plant. Coal is replaced again and again. And now, but disadvantage here, whatever the product are obtained in this case, whatever the nuclear wastes are there, that cannot be actually disposed of easily. So, disposal problem is there, and also this is here the very harmful radiations are generated here. If there is any leakage, they can cause destruction. So, this is there are the certain advantages as well as disadvantages of generating power by using nuclear reaction. Now, see here nuclear fusion reaction. So, we have seen nuclear fission reaction. Now, let us see nuclear fusion. See here in nuclear fusion what happened here, the element having the mass numbers approximately, that is A is you can say less than 10, take part in the nuclear fusion reaction. So, in the binding energy per nucleon curve, we have seen hydrogen has got the very less binding energy per nucleon. So, it combined together to form the heavier nuclei like helium. In this process, loss of mass takes place and the loss of mass gets converted into energy. So, in this process energy is released, but the product is here which is obtained, that is comparatively stable as compared to the reactant elements. So, in the nuclear fusion is actually a process in which two lightweight nuclei combine together to form a big nuclei, and in this process large amount of energy is released. But see here, in this process we need tremendous amount of temperature, or the very high temperature is required to combine them. That is why this is difficult to carry out this reaction. So, we can combine them, these two particles, by accelerating them to the high speed, or by giving them very high temperature, which cannot be obtained easily here. And one very important thing is here, the sun is the main source of energy of our solar system, and sun is emitting energy or the giving energy due to nuclear fusion reaction taking place inside the core of the sun. Main fuel inside the hydrogen is that is inside the sun is hydrogen. Now, see certain nuclear fusion reactions here, certain examples I am giving here with the energy here. Like first we have taken 1H1 and 1H1, that we can say one proton basically here. So, one hydrogen and one hydrogen, when they are fused together, that may be the by giving high temperature or accelerating them, one deuteron is formed, that is 1H2, and plus one positron neutrino, and this much energy is released here. So, in the fission of one hydrogen we get this much energy. Now, if we take another one like one deuteron, if the two deuterons are joined together, we get 2He3, that is an isotopes of helium. This is comparatively stable. There we can calculate loss of mass here, and in this case one neutron is released and this much energy is released, that is 3.27 mega electron volt. Now, let us take the third one, 1H2 plus 1H2, that gives us 1H3 plus this, and also in this process this energy is released. So, these are the examples of the nuclear fusion reaction. So, now the nuclear reactions are over, and in this chapter we have to do some numericals based on nuclear fission, fusion, and also you can say simply the calculation of energy.